move forward in talking about translations and how we actually perform them. So just hold on one. About that. Okay, here we go. So, we talk transformations in general. You start with some sort of pre-image, and then you do something to it to produce an image. Okay? So, and we're going to do all this stuff on the coordinate plane. Yep, so we can identify where things are at and use that to help us here. So I really need you guys to be quiet, please. Sorry. So if we start with our regular coordinate plane here, and I'll just make every box equal to 1 just to keep things simple. Just going to try and draw you a quick example of a translation. Okay, so let's say our pre-image is this triangle. Okay, so that's where we're starting from. Okay, so that's the pre-image. The starting point, or the starting object, whatever that is always called the pre-image. And then I'm going to take this triangle and I'm going to translate it. And it said that a translation moves every point in the pre-image, or in the figure, whatever you have, the same distance in the same direction. So as long as I draw another triangle that is oriented exactly the same way as this one somewhere else, then there was a translation that got it there somehow. So I'm going to draw it, let's say over here, like that. And to show that what you have is an image, instead of labeling it A, B, C again, we go A and put a little, it looks like an apostrophe, but we call it a prime. So that's A prime, B prime, C prime, like that. So if you're looking at just like a picture like this, and you're trying to figure out, well, which one's the image, which one's the pre-image? The pre-image is always the letters just normal, and the image is always with the little primes on it. Yeah? Just like a little line? Yep, it's just a little dash. Like I said, it's just like an apostrophe. So this would be the image then. Okay, so pre-image to image. And each one of these points moved, like we said, in the same direction, the same distance from the pre-image to the image. So it's also known as a slide, because you just slid it down to get it there. Okay? So the question then becomes, how can I describe to somebody else, if I have some sort of translation here, how it actually translated? So like how far, what direction did it go, that sort of thing. Okay? So if we look at this, we can kind of break it down into two components, which is why we have this thing called component form that we'll get to a little bit more later. But there's a horizontal component and a vertical component. So the question becomes then, how far left and right did it go? How far up and down did it go? And if you have both of those two pieces of information, you can write a little rule for how it moved. Question?
If you put all the lines together, it looks like one of those 3D triangles.
Kind of, sort of. Yeah, when you do that, it's true. So, take a look at how I graphed this thing, and let's start with the horizontal movement. So how far did this thing move just horizontally, left to right? How far did it go?
7?
It looks like, yeah, 7. Okay, so it went to the right 7, and then vertically, how did it move? Somebody else. Jason? Down 1, 2, 3, 4, 5. Yeah, down 5. Okay, so sometimes it just gets written like that. Right 7, down 5. That's how we translated it. If you want to actually write that as a rule, okay, it's also called a mapping, but in a rule, it's kind of like making it into a little bit of an algebra problem. So instead of saying right 7, down 5, we would write it like this. Okay, everybody see what I did there? Every point that is in the pre-image, you take the x-coordinate and add 7. You take the y-coordinate and subtract 5. Okay, isn't that exactly what we did? To move it to the right 7, I had to take every x-coordinate of all the points in the triangle and add 7 to them. And to move it down 5, I had to take every y-coordinate that I had and subtract 5 from every one of them. There you go. Okay, so this is called the rule for this particular one. Okay, and sometimes you'll be given what the rule is, and you have to figure out, okay, if this is the rule, and here are a bunch of points that are the pre-image, tell me what the images are of all of them. Okay, so we're going to try that next. I'm going to do a completely different problem here, but I'm going to give you a different rule. We don't even need to graph it to do this. So let's say our rule is xy goes to minus 2y plus 8. Okay, so we're going to start with that rule. And we're going to take a bunch of pre-image points and see if we can turn those into image points. So I'm going to make a little chart here to do this one. All right, let's just do 3. Okay. Now, if you wanted to, you could take every one of these pre-image points, stick them on a graph, and say, okay, I got to take each one of these points. I got to move them to the left 2 and up 8, and just, okay, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 1, 2, 3. And you could, like, map it out and get it that way. Or you could just think about it as like a substitution problem, right? You take the numbers and just plug them in, see what you get. Gets you the same thing. Okay, so 0, 2. If my pre-image is 0, 2, what should I have as an image then if I follow that rule? Yeah. Yep. Negative 2, because 0 minus 2 is negative 2. And then 10, because if I plug the 2 in up here, 2 plus 8 is 10. Okay? So, real quickly, get the next 2. Do those on your own, and then I'll write down the answers here in just a minute and you can check them. So you should have negative 5, 7, and 2, 11, right? Okay. So any points on a figure, if you know the rule, it's really just that easy. You plug it in and go. Okay? A way that you might be asked to do a translation by hand without having to graph it out and all that kind of stuff would be using a vector. We talked a little bit about that with our vocab. So let's say assume the vector 2, negative 5, and remember vectors have to have these little brackets on there. Describes the translation of the square below. So I'm going to graph a quick square here. All right, what are we on the alphabet here? So D, E, F, G. Let's say where each box is equal to 1 again on this graph. Okay, so we're looking at that. All right, so I want to know what are the coordinates of the image of this translation. Okay, so this vector, remember a vector was like kind of like pointing the way of whatever direction the translation was going to go. Okay? And in this case our vector is 2, negative 5. So every one of these points, if you go 2, negative 5, this is the x and the y of the vector. So like let's say we start at like point E, okay? So if I'm going to put the vector 2, negative 5 off of E, it's going to go over 2, 1, 2, and then down 5, 1, 2, 3, 4, 5. Okay? So that vector, it looks kind of like a ray, right? So it's basically just a ray that is pointing the way to where it needs to go. Okay? So from E down to here, so this would be your new E prime. Okay, and then you just do that for all 4 of them, and it points to where those new points should be, and it should make a new square down here once you're done. And I have a picture on this one just to kind of show you what it looks like, but again, you can do this without actually having to draw this thing out, right? I mean, at least once you've got one point, you shouldn't have to keep drawing the vectors every single time, but there's G prime, there's F prime, so it got a little jumbled at the bottom there, but you get the idea, right? Each one of these points, you put that same vector onto it, and it's going to go over 2, down 5, boom, pointing right to that one. Over 2, down 5, boom, right to that one. Over 2, down 5, and boom, right to that one. So you got all these vectors kind of just pointing right to here, right to here, right to here, right to here. How do you do this problem, though, without actually having to draw the image? Like, if I had just the coordinates of these 4 points, so like D is at, what, negative 4, 3? So if D is at negative 4, 3, how do I get the coordinates of D prime just knowing that the vector is 2, negative 5? Yeah, no. Yeah, it's kind of like the rule, except it's just kind of in condensed form, right? 2, negative 5 means add 2 to x, subtract 5 from y. It's telling you these two numbers, right? It's doing the same thing. It's just written a different way. Okay? So, negative 4, 3, I got to add 2 to negative 4, negative 2, and then I got to subtract 5 from 3. So, negative 2, right? So D prime should be at negative 2, negative 2. Take a look at the picture. Is that the case? Yes. Right. Okay. So if I keep applying this rule just like I did the other ones, E is at negative 2, 3. F is at negative 2, 1. Oops. And G is at negative 4, 1. So I can very quickly, just like I did the mapping, or just like I did the rule, get E prime, F prime, and G prime just by adding 2 to every X and subtracting 5 from every Y. So let's see where we should end up here. So then E would be at 0, negative 2. F prime should be at 0, negative 4. And G prime should be at negative 2, negative 4. Just doing it that way. And you can look in the picture and, yep, those are all exactly where they're supposed to be. Okay, so what I'm going to do with you is just going the opposite direction with it. If I show you a picture of a translation again, can you tell me what the rule is, and can you write that as a vector? And if we can do that, I think we're good. I think we got everything we really need to go over here. So I'll move over here for that one. And actually, I'm going to make these the primes up here. I'm being sneaky. All right, and I'm going to put some scale on this thing. So there's 2, 4, 6, negative 2. All right, so again, every box is 1 unit, just so we're staying clear on that. Okay, so what I'd like you to do on this one is to describe the translation using a vector. Okay, so how far did it move? Vertically, horizontally, and make that a vector. All right, so who thinks they got it? What are the coordinates of that vector? Jason? You guys agree with that? He's almost got it. Actually, 1, 2. Did you mean right 5 down 3? Now here's the thing. It's still not technically right. I know, but I just want to point something out because I'm sure other people did this. Okay? You got to think about where's the image and where's the pre-image, right? The image is here. The pre-image, where you start, is here. Okay? So it should be left 5, up 3. Right? Now, if it's left 5, up 3, and I said I want this as a vector, right? So Glee, what would that be as a vector then, Mr. McKinnon? Right, -5, 3 in the little brackets. Okay, like that. That would be the answer to that one. Good. Okay, I think you guys got enough to chew on here where you should be able to get the homework without too much trouble. Good. Okay, so I'll let you get started on that.